Logic gates, timing diagrams. In this presentation, we're going to be looking at, well, logic gates and timing diagrams. Jeez. Timing diagrams offer a way to visualize the operation of inputs and outputs in a logic gate system. So really, you're using something that looks like this here on the left-hand side in, well, sort of replacing a truth table. It's simply another way to represent the information which kind of takes into account time. I have a number of different examples that I'm going to go through of AND, OR, and NOT gates. And what you'll notice is that each of them has different time stamps or time signatures, time, I don't know, sections. Time section 1, 2, 3, 4, 5. And since this is an AND gate, you would expect two highs in order to get an output that's high. And so the way that the signals are shown is a low would be down here and a high would be up here. And they are three separate lines of signals. Two are input and one is an output. That would be X over here. So we can see at any given time reference that we should be able to tell what the output would be of the AND gate. Here's another one. This is an OR gate. Same idea. We've got a high here and a high here. And since this is not an exclusive OR, it's just a standard OR, that means that we've got a high signal here as well. So any section along here, a low, that would make a low. A high and a low, that would make a high. And so if you understand the truth table, you should be able to determine what the output would be at any given timestamp. Here's a NAND gate. Now NAND gates are a little bit different, right? They've got a inversion or circle dot, whatever you want to call it, on the output side of the AND gate. So now we've got a high and a high, that actually makes a low, right? A and B are both high during these 4 time intervals. Here, 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 and here. Therefore, X is low. So a NAND example. A NOR example. So we see here, we've got a high and a low, and that equals a low on the output. If we look here, we've got a low and a low, that makes a high. And then over here, we got a low and a high, that makes a low. Here's an example. I've got 7 different examples that I'm going to go through. So I'm going to show them each, have a little pause in between, and then go to the next one. So this is an AND gate. Try to determine when there's going to be highs and lows. And here are the answers. So a standard AND gate, we need 2 highs in order to get a high in the output. And so we can see that at each of these 4 time intervals. Here's example number 2, another AND gate. Try to determine what the output will be at each of these different time intervals. And here are the answers. You can see here that I've got a high and a high just for this small section, and that then gives me a high as well. Over here, that's a low, and that's because I've got a low and a high input at these points. Example number 3. This is a 3-input AND gate. And the answers. Now you'll notice that there's only 2 times that this goes high, and that's because in an AND gate, you need all 3 to be high at the same time. So that's high, and that's high. Over here, we can see a high, and a high. Example number 4. And the answers. We can see here, it is an OR gate, which means it doesn't matter which one of the inputs is high, the output will go high. Example 5. And the answers. Example number 6. This is a 3-input OR gate. And the answers. And what you'll notice with a 3-input OR gate, this is not an exclusive OR, but it's just an OR gate. And that means that we need to have a high, and then we would need another high, an OR gate. So any one of these can be high in order to make the output high. So in this interval, input A is high. In this interval, input B is high. And in this interval over here, C is high. And when C is high, it doesn't really matter what's happening to the inputs of B and A because, well, the output's already high here. And finally, example 7. And here are the outputs. We can see here, this is high for the entirety of this first section here. C is low, B is high, A is high. Over here, I've got a high, and this is a low. And it's because I have the inversion on the output side of my AND gate that this output high and low track is seen. And finally, number 8. And the answers. A little bit more simplistic, we can see here it's a low for the whole time here, a little bit high, and a little bit high at the beginning and the end. And that's how you do logic gate timing diagrams.